Welcome back. Problem 5.21. So draw the shear and bending moment diagram for the beam and loading shown. Determine the maximum normal stress due to bending. So this is beam AB, that is overhanging beam. The loading at point C is 25 kips. At point D it is 25, and at point E the loading is also 25 kip. The length of this beam is shown as the total length is 2 plus 6 8 plus 10 plus 11. So total 11 feet of the length of the beam is given. So you have to draw the you have to find the maximum bending due to maximum stress due to bending, and that cross section of the beam is given as 12 by 35. So first step is to find the reaction forces. You can see that we have support. Where is the problem? Okay, so you first step is to find the reaction forces at point A and B. If you remove these supports at point A and B, so we can replace them by a force. So here force will be RB and here the force will be RC. So you have to apply the equilibrium condition in order to find these unknown reaction forces. So first condition, that sum of all moments about point B is equal to 0 and taking the counterclockwise movement as positive. So movement about this point is equal to 0. So the forces which is producing movement are these forces that produce movement about this. So this force is producing counterclockwise movement, and this force which is also producing counterclockwise, and similarly this force is also producing counterclockwise movement about point B. At point B, this force which is RC is producing clockwise movement. So we will write them. So 11 into total length of the beam is 11. So 11, 20, first we will write 25 into 11 feet. This will produce counterclockwise, so it will be positive. The other one is this RC. So RC into perpendicular distance will be 10. You can see 11 minus 1, which is equal to 10, and it is producing clockwise movement, so it will be negative, plus 25 into 25 into perpendicular distance is this 8. Okay, so 8 feet plus 2 into 25 into perpendicular distance is 25 is the load and perpendicular distance is 2. So their sum must be equal to 0. So when you calculate it, you will get this. This is RC, not RA. This is RC. So you will get this RC will be equal to 52.5 kips. Now we will find this RB. For that we will apply another equilibrium condition, that sum of all forces about point C is equal to 0 and taking the counterclockwise movement as positive. Now you can see that this is point C and we are going to take the moment about this point C is equal to 0. So first force which is producing movement is this one, and it will be counterclockwise. The second force which is producing this movement will be clockwise. Similarly, this force will produce a clockwise movement, and this RB and the perpendicular distance is this one, it will produce counterclockwise. So their sum must be equal to 0. So what we'll write is 25 into 25 into perpendicular distance is 1. This is clear. Plus minus 25 into perpendicular distance is 2. This one, and perpendicular distance is this 2. Clear. Minus 25 into perpendicular distance is 8, and the last one plus RB into total perpendicular distance is 10. Their sum must be equal to 0. So from here when you calculate it, you will get RB will be equal to 22.5 kips. Now we have this RC and RB. You can plot them in order to find the shear force diagram. So let's move, and we will move towards shear forces. So shear forces. Now at point A, at A, we have this load that is given as, at this point we have a load of 25 kips. So we have 25 kips. I will also plot it. So you can see this is the, here we will draw the shear force on y-axis. You have to take the shear forces, and on x-axis it is the length of the beams. A, C, D and E points are also mentioned over here. You can see them clear. So we will plot each points. Okay, so at point A we have 25. So 25 will be somewhat here, some minus 25, because the force is downward. So it will be this point. Okay, from A, when you move from A to C negative means before, not reaching the C point exactly, but just before the C. Okay, so this is A point and this is C point. So you can see the load will remain the same. So from A to C it will be again, that is minus 25 kips. Okay, so A to C, C is this point. So from A to C it will be constant. Now at point C, at C, you can see at point C, let me clear it. At point C you have this reaction force as well, this RC. So RC is 52 kips. So minus, this is minus 25. So minus 25 plus 52.5 will give you 27.5 kips. So load at point C will change to 27.5. So 27, let 27.5 is somewhat here. So load will change from this to this. Okay. Now from C, this is C negative, from C to D negative, or from C plus, moving away from C to D negative, this load, you can see this load will remain same till point D. So let this is the point D. So this load will remain same, at it will be 27.5. It will be 27.5 kips. Now at point D we have a load of 25 kips. So at D we have 27.5 minus 25, which will be equal to 2.5 kips. So 2 will be somewhat here. Let's say it's this. So load will change from 25 to 27.5 to 2. And from D, away from D to D, E negative. So the load will be same. So we will first write from D plus to E negative. This load will be 2.5 kips. So I will plot that. This will be horizontal. Now what at D? At E. At E point, you can see at E point there is a load of 25. So the load will be 2.5 minus 25, and that will be equal to minus 22.5 kips. So minus 22.5 will be somewhat, you can see here if I project it. So the load will change from this to this. Okay. Now from E to B, this load will be the same. And from E plus to B, this load will be minus 22.5 kips. And at RB you can see this is plus 22, so it will horizontal, and at point B the load will go upward to 0. So this is your shear force diagram. I will point out this. At this point we have minus 25 kips, this is 27.5, this point is 2.5, this is minus 22.5, and this is 0. So this was your shear force. Now we'll find the bending moment. One method is that you can take the areas which we discussed in our previous example. Now we'll find bending moment by using the equations of bending moments. So bending moment. So at C, what at C? At C you can see you have to cut the beam at this point and you have to draw the free body diagram. So this is point A at which we have 25 kips load. This is point C. So when you cut the beam, so there will be a shear force and external movement. From A to C the distance was 1 feet. Okay, 1 feet. So we'll apply equilibrium condition that sum of all movement about point C is equal to 0 and taking the counterclockwise movement as positive. So only producing movement is 25 into perpendicular distance is 25. Perpendicular distance is 1 and it is producing, you can see, a clockwise counterclockwise movement, so it will be positive. And there is this external movement and this is also positive, so movement is equal to 0. So it means that movement is equal to minus 25 kips into feet. Also the assumed movement, external movement, is wrong. That must be clockwise. Okay, so this is movement at point C. Now we will move toward point D. At D, so I will show you, you have to cut the beam over here and you have to draw the free body diagram. So I will show you. So now this is the beam, clear. So this is point A where you have 25 kips load. This is point C where you have RC, and this is point D where you have cut the beam, so there will be a shear force and external movement. This distance was 1 feet, and from D to from C to D the distance is 2 feet. So this is 2 feet. Okay. So we'll apply equilibrium condition. Sum of all movement about point D is equal to 0. So 25 into perpendicular distance is 3. And that is producing this. You can see that this force is producing counterclockwise movement at point D. So it will be positive. And now this RC, which is producing a clockwise movement about this point. So RC is 52.5. So 52.5 minus 52.5, which is RC into perpendicular distance is 2, plus external movement, this M, their sum must be equal to 0. So when you calculate it, you will get movement is equal to 30 kips into feet. So this is movement at point D. Now we will move toward at point E. So you have to cut the beam at point E, and again you have to draw the free body diagram. So I will show you. This is point A, which is 25. This is point C where you have RC. The perpendicular distance is 1 feet. From at point D we have a load of uh, at point D we have a load of 25 kips, and the perpendicular distance from point, this is point C, this is point D, perpendicular distance is 2 feet, and this is point E where you have cut the section, so there will be a shear force and external moment M, and distance between D and E is 6 feet. Okay, so applying the equilibrium condition, so at point E, this is point E, so at point E we have one moment, the other moment due to this force and perpendicular distance, the second moment is due to this force and perpendicular distance, and third moment is due to this and perpendicular distance is this. So starting from point A, so we can say that this will be 25 into perpendicular distance is 6 or 2 8 in plus 1 9. The other one is, this is positive, so this RC is 52.5 into perpendicular distance is now 8 plus 25 into perpendicular distance is 6 feet plus M, there sum must be equal to 0. So from here you will get this moment will be equal to 45 kips into feet. Now you can draw them on shear force diagram. At point A we have moment will be equal to 0 because x is equal to 0, start of the beam. At point C we have a moment of minus 25 kips, so minus 25 will be somewhat here, there, so you can join them. This will be a first degree line because you can see that from A to C it is a 0 degree line, a line with having 0 slope, so bending moment will be the first degree line, and that will be, the slope will be decreasing because the shear force is negative. So this is the point from A to C. Okay, now at point D you can see that at point D we have a moment of 30 kips, so 30 is this point. Again you can see that this is a 0 degree line, a line having slope of 0 degree, so moment equation will be first degree line, and since it is positive, so slope will be increasing, the line of the slope will be increasing. So we will join this point with this. Okay, now at point E, so you can see at point E we have a moment of 45 kips, so we will move toward 45, so 40, so 45 will be here because this is 40 and this will be 50, so to 45, and again this will be a line of 1 degree. Okay, at point B we will have a slope equal to 0 because you can see you have to close this, so at point B we have a slope equal to 0. I will also explain why the slope will be 0. This will be okay. So if I draw it closely, okay, so this you can see that area between E and B is minus 25 and 22.5 into this width, and this width is 2 feet, so minus 22.5 into 2 will be equal to minus 45. So that's why minus this here at moment we have 45, and at this point we have moment minus 45, so plus 45 minus 45 will bring it to the 0. Okay, so I will write the values. So at this point we have minus 25 kips into feet, minus 25. At this point we have 30 kips and into feet, and at this point 45 into feet. Now from this bending moment we have seen that we have maximum bending moment of 45. So I will write it, maximum bending moment is equal to 45 kips into feet, and in inch it will be equal to 45 multiplied by 12. 1 feet is equal to 12 inch, so it will be equal to 540 kips into inch. Now we know that maximum bending stress is equal to maximum moment divided by section modulus. So moment is 540 kips divided by section modulus. So section modulus can be checked from the property table of the steel rolled section. So S18, what was given in it is S12 by 35. So you can see S12 by 35. So here if you move in this direction, so you can see that this is the value 38.1 cubic inch. So 38.1 cubic inch, and when you calculate it you will get normal stress comes out to be 14.17 ksi. So conclusion is that maximum bending stress is 14.17 ksi. So this is the answer of our this problem. I hope you have enjoyed this video and you are now fully aware how to draw the shear force and bending moment diagram. And again, if you have any question, you can ask me in comment section. Thank you for watching.